Good morning, everyone. As we step into the final day of this enriching faculty development program on blockchain technology and its applications, we are honored to welcome our distinguished academician and researcher, Dr. Venkatesan Subramanian Sir, Professor at Department of Information Technology at Indian Institute of Information Technology, Allahabad. Sir has an exceptional academic and research background with expertise in blockchain technology, distributed system, and cryptographic security. His work spans across cutting edge domains such as secure communication systems, cyber physical systems, and IoT based applications. He has guided several scholars, published numerous research papers in reputed journals, and has been deeply involved in exploring the intersection of security and blockchain to build robust, transparent, and future ready digital ecosystems. Today, he will be sharing his insights on blockchain technology and NFT for evidence management systems, offering us deeper understanding on this topic. Now, I would like to call Dean Research and Innovation Dr. Brijesh Kumar Chaurasia sir to present the token of appreciation to our esteemed speaker. Let's welcome our esteemed speaker with a huge round of applause. Guys, please.
So, good morning, everyone. Okay, so thank you so much for inviting me here. This is the first time I'm here. Hope I am audible. Okay. So, what I will be doing in my talk, first let me introduce my lab or our lab briefly for some 5 to 10 minutes, and then I will discuss what are the works we have done in general as well as related to blockchain, and then I will move on to the blockchain technology. Okay. So we have our lab there, and your dean was there for a long time. So the lab is network security and cryptography, but now we are planning to make it as cyber security, center for cyber security, and we do research in all the areas that are on cyber security. So you can see here, so we cover almost all the topics. So even though the quantum is not there, but we have already produced one student on post-quantum cryptography. So there are multiple students working, including BTech students. I have not listed them. So we have almost 10 PhD students and 20 MTech students are working, and we have 5 faculty in the research group, and 2-3 are the associate member of the group because they work on different area. Like in case of ML, they are fit into all the areas. So we requested them to join in our group. So there are various things we have done. So this was the achievement of the last few years. So we tested, we have a project on IoT security, and we audited the access points. So the TP link and other access points, and we discovered various vulnerabilities, and we reported and got the CVE, and these are the sum, and we also reported 8 more. Even in the camera, we found the vulnerability, the cameras of TAPO as well as the CP+. So because we want to consider both Indian make as well as the foreign make, and who is the manufacturer of TAPO. And our students won the hackathon prize last year. 1 lakh they won from the PNB hackathon, and also one of our students, he presented his work on the storage efficient blockchain in the British Blockchain Forum, and he got third prize or second prize in that. And we developed various tools. So these are the tools we have developed, and it is available for anyone's access. And this particular one, the testbed, is specifically for blockchain, and it is mainly for the researchers. So what we do in the what we give in the testbed is we give the entire infrastructure. So considering the IoT, so we have the testbed with almost 6 Raspberry Pi, then 2 mobile phones, and there is 1 BeagleBone and a server. So whoever want to access, so we give the web access. Whoever want to access from their home or their place, they can access the complete infrastructure, and it will be given to them for that period of time. So nobody else will be using. Even if they want to join into the network, they can join through the remix by giving the ID of our network, not the main net. So in that way, you will have your own network, which is the complete hardware we are giving, and there is no such testbed exist. And when you are going to run your, let's say, the smart contract, so you can you have to get the performance, like in case of CPU utilization or the memory consumption, as well as the how much energy it is consuming. So everything will be given by the testbed. So you have to just deploy your smart contract, and then you have to see the performance. So the remaining things will be handled by our script, whatever was written. So right now the testbed is not running because we implemented the testbed considering the proof of work. Now we are planning to move to proof of stake. So our students are working on it to reinstall with the proof of stake. And we have funding of almost 30 million INR for our lab. And this is one work what we have done in this year beginning, so which I like very much, because everybody talks about LLM. So what we have done is we have taken 5 different LLMs, and we thought of to analyze whether it can produce the secure code or not. See, this is not related to blockchain, but just I want to share that what are the works we are doing. So what we have done is we took all this. Maybe it's not clearly visible. So we took Gemini, Grok, Claude, ChatGPT, and then one more also. Even I could not remember that, or I cannot read it. Maybe I can see from here. DeepSeek. So we have taken all this, and then we asked the LLMs to generate the web code. The web code is just for the login. So there will be a page where user has to enter the username and password, and that get validated in the next page. These 2 pages we asked the LLM to generate. So it produced the code, and then we prepared the security requirements on our own, considering the OASP and other things. So based on our experience, we have prepared the set of requirements, and also we have prepared that if these requirements are not implemented, what will be the risk. So then when we analyzed, if we see here, so we categorized the risk into 6 levels, that is extreme risk, very high risk to low risk, and we found that none of the LLMs are giving the secure code. So when we submitted the paper to the reviewers, so there were comments, they have rejected the paper and they have given the comments like, you should have asked multiple times. That means you have to change your prompt iteratively and you would have asked. But we denied to respond to that, because we want that if somebody comes who is not aware of the security, he will simply say to ChatGPT, I want the code with security. If he knows each and every security requirements, then only he can ask, or he can prepare the prompt accordingly. But in this case, if we consider that non-security professional is coming to ask the LLMs to generate the code, in that case we cannot expect that he will give everything in detail. So he will simply say you follow the security standard, maybe NIST or some other standards like ISO, and give the code. So that the same way we have asked, and we found that none of the LLMs were generating the secure code. Yes. LLM was generating. Ah, yes. Yes. So we have given, you have to prepare considering the database and secure authentication to be there, and language is PHP. So we have given all this. So accordingly it has generated, and we are planning to go for others like React.js and all. But what happened in case of React.js, they just use the library. So in that case, it will be claimed as that they are implementing the security. So that we are looking into, maybe our students will work on that. So otherwise, no LLMs are giving the secure code, and overall if we see in this analysis, Grok is somewhat better when compared to other LLMs in generating the code. And even reviewers asked that how we will reproduce the result and check it. And what happened in some cases, the LLMs will be keep on learning and it will improve, because if we ask the same question now, it may give somewhat improve. And also we can set the temperature and so many other parameters, so it can give better, and sometimes it may be worse also. So what we assumed is, let's say if someone is coming who is not aware of anything, he goes and asks, and whether the LLM generate the secure code for him or, because these days you know that we don't need to write the code. So one of our earlier directors used to say that we don't need now the coders, we want only the prompt engineers. So we have to prepare the prompt accordingly and give, and that prompt engineer is also going to be replaced by the agentic AI. So we will give the request, agentic AI will prepare the questions and accordingly questions according to the domain, and then it will produce the out. So this finally it got accepted in the conference, and our students are going to present in IIT Indore soon. And then with respect to blockchain, so we used blockchain as a tool, or we can say the technology, and we implemented the authentication on it. Using that, we implemented the authentication. So our requirement is, let's say that you all are sitting, you know each other, but now I am coming in. You people are not having any information about me, just I am coming, and you have to find out whether I am the right person or not. So normally what we do in this case, we go for the reputation. Okay, so the same thing we have implemented using the blockchain. And when we talk about the reputation, we considered that the network. So I will discuss about the permissionless and permissioned blockchain. Maybe you are aware of that also. So we considered it is a permissionless blockchain, because our permissionless application. If it is permissioned, definitely that person is known. We consider like vehicular network. So all the vehicles are registered with the RTO office. So in that case, it is the permission network. But our plan was considering the permissionless. Even that same vehicular network, we say that we go for permissionless, because there is a possibility the number plates are there, right? People can fake it. Okay, and then they come and claim, I am so and so. So considering this, we thought that we assume that there is a permissionless network, and we want to ensure the authentication. So we used the blockchain, because the authentication information will be stored in the blockchain, and the participants will be doing multiple activities, off-chain and on-chain activities, and from that the score will be computed. So when I am making any authentication model, so I formulate some equation or whoever it may be, and we have to validate that whether it is properly made or not. So there is a tool which is developed by University of Pennsylvania. So that tool, they name it as QTM, peer-to-peer trust simulator. So we used that tool and analyzed. So we developed two trust models, one considering the permissionless network and another one is considering the permission network. For example, in our case, we considered the smart metering infrastructure. So when we analyzed, so this particular line is, if we don't implement the trust model, how it behaves. Because if we don't implement, there is a possibility of identifying, that is 50-50%. So that is what this line refers. And according to our model, it is going more than this. So what this indicates, if your authentication model or the equation or the technique you are developing, if it is higher than this, if it is higher than the none model, it is considered as yes, yours is good. So then what we have done is, in this particular tool, there are many things that are not present. So we want to do the authentication considering the blockchain environment. And in the blockchain environment, we need multiple things, and that is not present in the tool. So then we developed our own simulator. So in that simulator, we have considered all these parameters, and when we have tested using our tool, that model what we have developed, that same mathematical model for the authentication, here you see that it fails to produce the right to identify or to evaluate someone is correct or not. In that tool which I was showing previously, there it shows it is better, but in our tool it shows that it is not better, and we have considered these two metrics and then accordingly we have evaluated. So now it seems like whatever model we have designed, that won't be the perfect one. We have to modify the model in the sense that computing the trust score or the reputation score, I should not say trust score, it should be reputation score, because trust refers to individual, reputation refers to multiple. When multiple people gives the trust score, from that only we bring the reputation. So now it says to us that we have to modify. So this tool is available, it is there in our lab website. The entire code you can download and you can use it if required. So if you are developing any authentication model, you should evaluate that whether it works properly or not. So either you may use the Pennsylvania tool, or you may develop yours, or you may use ours. But I have shown that ours is better when compared to that one, and number of parameters they have very limited because they were not considering the blockchain, but we have considered the blockchain and accordingly we have added multiple parameters. So now let me move on to the blockchain. If any questions, please let me know, otherwise I will move on to the blockchain. The test, no, that code. Okay, so you visit security.iita.ac.in. Okay, so there is a tab, you can see resource. Okay, you go there and you can get. So the complete description I have given. What are the functions and what is the task of each and every function. Paper is separate. That was published in the conference of the blockchain, and there is an annexure we kept separately that gives the entire detail of the code. So the code is written in the Go language. Okay. So now let me move on to the blockchain, and I hope you very well know blockchain. I can say that you know better than me. See, I started in 2016 to learn about the blockchain. I said the same story to her when she was in our campus. So when I started in 2016, Bitcoin came in 2009, you know. 2008 it was formulated, but 2009 it came into the picture, and I was not aware. Even my colleagues were discussing about Bitcoin once. I was not getting what they were discussing. And in 2016 I was told by a professor from IIT Kanpur, Professor Sandeep Shukla. He is very well known scientist in cyber security. He asked me, you work on blockchain. So I was searching on Google. I get that in AES and DES, maybe you must be knowing that CBC mode, those things only coming. Almost for 10-15 days I was going through that only. Then some way I got the term Bitcoin, then I searched, then I found lot of material. But now you know, you type BL in Google, automatically the remaining will be filled. So that's what the popularity gained. And in 2018, so we conducted one FDP. After that, we thought of to write a book. So we wrote a book, and then again in 2020 or 2021, we organized another FDP. So that time I thought, let me go through or revise the topic not from the book, from the internet source. I have seen that massive change, whatever we have written and whatever now, it is completely different. Then we thought, no, we will drop the book, we should not go with this because people will be misleaded with this document. Except the basic, there are many things. We were discussing about IOTA, that is one of the implementations. It is not the linear blockchain, it is the directed acyclic graph. Earlier they were having milestone concept, like the developer will be approving the transaction. But later what happened, they come to the consensus protocol in the later versions. So we have not covered that. So then we thought, okay, we will hold it. Again we will redo all the things, then we proceed. But due to time, we were not able to continue in writing that, but still we use that book for our students because that covers some of the basic things. Okay, so now we know that blockchain is the distributed database or decentralized system, and the advantage of using this is immutability. So that's what the main reason, and another is decentralization, people go for it. And here whoever the parties are part of the blockchain, everybody will be having the exact copy with some time delay. Let's say if I am having something right now, you may not be having in time t1, let's say, in time t2 you will get. So because it has to spread layer to layer, because I am not connected with everyone directly, we don't have the mesh topology. Even though we talk about distributed systems, we don't have the mesh topology. It is peer to peer, but with so many nodes. Let's say that if I give to this, they give to next, so like this way the blocks or the transactions get propagated. So since everyone is having, it is not possible that someone will make the change and others will agree on that. And we know that when they are going to make that to be successful, they should have the majority. So majority in the sense, either they can have with the computational power or the number. So if it is proof of work, they should have the computational power. If it is proof of stake or any other practical Byzantine fault tolerance, then they should have the majority of the people, so that they can do whatever they want, even though it is illegal. And the important thing is, when we say immutable, we should not say that blockchain is immutable. It is mutable, but provided with certain condition, then it is immutable. So if we see in case of proof of work, if you all are having, let's say 3.2 gigahertz processor or 1 gigahertz processor, you all together will be having 60 gigahertz processor. If I am going to have 100 gigahertz processor, then I am going to win the race and I will make the change. See, making the change means I am not going to change the data and produce the same hash value, because the hash algorithm what we use is considered as the collision resistant. So it's not possible for me to change, but I will replace the block. So in that way, I will bring the mutability. So when we say immutable with condition, okay, if the majority is not with the attacker, then it is not possible to make the change. And this is the structure. So this we can consider like Bitcoin. In case of Ethereum, it contains so many headers, and even in Bitcoin also they have changed. Earlier there were 4 headers, now it is more headers that are present in. And we know that this is the header part and this is the data part. This hash is computed, the parent hash is computed considering this will not come. However, this is covered in the Merkle tree, the root header is present in that. So like this, the blocks will be keep on growing. And the features, if we see, it has integrity, availability, transparency, decentralization. Finally, it gives the trust. That's why people move on to the blockchain. So we can see whether there is a need for blockchain or not. People want to use blockchain because of that some magical term. That's the only reason. And if we see the types, so we can classify into public or permissioned blockchain, permissionless blockchain, and another one is the permissioned blockchain. So in case of permissionless, anybody can join and everybody is considered equal. There is no master slave concept. But in case of the permissioned, we know that there will be some administrator who will be responsible for adding the person and also deciding the quorum and all. And there is one more which is called private blockchain. So private cannot be compared with permission. So permission is different. So let's say I simulate Ethereum. So Ethereum, you all know that it is the public blockchain or permissionless blockchain. So now when I take that code and I run 3-4 nodes, not connected with the main net, I am creating my own network. So when I create my own network and I am using the permissionless code, so now that is private network. Okay, this is what referring to the private blockchain. So now how I will ensure that it is private? So what is the role of the Genesis block? You all know that that is the very first block of the chain, and whoever is having the same Genesis block, they are into one network. If the Genesis block is different, if let's say that I have some Genesis block and she is having another Genesis block, we are not on the same network. So now in case when I am going to run the private network, I created my own Genesis block, and that Genesis block is known only to some 3-4. I am not sharing with others. If I share with others, they will also be part of the network. So now how I am making the private network? Since I am giving that Genesis block to only few, so the same permissionless now become permission network. Sorry, private network. So this is what is called as the private blockchain. And in case of the permissioned blockchain, further we can divide into public permission and private permission. So if we see the blockchain, there are two activities we will perform. One is read operation and another one is the write operation. So when you create the transaction, it get updated, the state change happens. So that is referred as the write operation. Sometimes you read it. So we call that as the read operation. So when it goes for the private permission, we don't give read and write operation to anybody outside. So only the insider, that whoever is part of the permissioned blockchain, only they can do the read and write operation. But if it comes to public permission, write operation is only with the people who are part of it, but read operation is by anybody because they can validate. So when there is more validation, then we can trust the chain more, because even if internal things goes wrong, the outsiders will identify, and you all know that there is always possibility of the insider attack. So now the next question is, so we all know Bitcoin. I don't know now whether it has reached 1 crore or not. It might have reached 1 crore, right? Not yet. Okay, but it must be closer. 92 lakhs. Okay. So when I started, I said 2016, right? That time it was 47,000 rupees. So I made a mistake. Otherwise, I would have been crorepati now. Okay. So the Bitcoin, do you think anybody can kill Bitcoin now? Let's say India want to kill. Is it possible? Can India kill the blockchain? Sorry, Bitcoin. Now let's say the entire world comes to kill. Is it possible to kill? So some are yes, some are no. Okay. So yes is the wrong answer, no is the right answer, but I want the justification. Okay. See, he is saying that market crash will happen. See, you can make legally the Bitcoin is killed, but illegally people will be using it. The dark web market will be running in the Bitcoin. So that's the problem with the permissionless blockchain. It's not so easy to kill, or I can say it is not possible to kill. See, if India says that we want to kill blockchain, that Bitcoin, only in India it will not run. In remaining countries it will run. If the entire world comes together, the world will stop, but the underground will be working on the Bitcoin. So that is the major problem with the permissionless. If we go for permission, so then what happens? Let's say if RBI comes, RBI is already in the process, they also released some. If they are having the blockchain based currency and it is the permission, if they want to kill anytime, they can kill it, because that administrator can do anything. But in case of the permissionless, it's not possible. So that's why it is going with permissionless blockchain is somewhat dangerous. And now everybody is competing to take part in the Bitcoin because of the value, whatever it is now. So any of you having Bitcoin, but it is getting recorded, be careful. But anyway, that's not illegal, but you have to declare for the tax. Okay. So now what are the challenges? If we, let's say, in cryptocurrency, there is no problem. People will do contributing in it. So I always tell in my blockchain class, the world is business world. Means if I have to do something for you, definitely I expect something from you. And if you don't give anything, why should I do? Okay, that is what with everyone's mind now. That becomes nature now, not like previously. Okay, previously people want to contribute. Now that is changed. Why should I contribute? Every contribution ChatGPT will be doing. Okay, so we have to give something, then only we will take the work. So if we see the Bitcoin and all, so what happened? If you do the task, you are getting the reward in the form of mining reward or in the form of the transaction fee. So that's why people are motivated to go for mining or contributing to the blockchain Bitcoin growth, or the liveness, I can say, instead of the growth, liveness. So now I want to use the same blockchain to the application, for example, the grade maintenance. Okay, for example, the exam cell. So for that I am going to apply. Now who will do that process, that mining process, or only the mining process, because that is considered as heavy. So who will do that, and why should they do it? So it will be unnecessary for them. So nobody will come. So that is the major challenge. But anyway, before going to that, let me ask one question. So in Bitcoin, there is a transaction happening. Two parties are involved in the transaction. One is sending, one is receiving. And there is a miner who is going to get the transaction fee and then the mining reward. So now let's say I am the one mining the block. I mined the block number 10, let's say. Now I cannot give it to everyone directly. As I said already, I give it to my neighbor. My neighbor will give to the next neighbor, next neighbor, next neighbor. So now the question is, I have mined. Who will take the advantage? I am going to take the advantage, that mining reward or the transaction. Now I give the block to these people to further forward to others. Now why should they forward? They are not going to get any reward, right? Why unnecessarily they will be benefiting me? Are you getting this? So they will not forward until they get something. They will not forward. This is the real fact. See, this is not college. The teacher will say, then you give the paper to, I always give the paper to the friend. I ask them to give it back or pass it. Okay, that will not happen in the real world of Bitcoin. Nobody, as I said, nobody will be trying to do any voluntary job. So what happens? Why they will be forwarding? Let's say I give my block, let's say block number 10. So they know that block number 10 is mined. So now they started to mine the block number 11. And then block number 10, mine, they have not forwarded, but they considered my block as parent block and they mined the block number 11 and they give it there. So now she is having block number 9 and then she got block number 11. Now will she accept the block number 11? Because she needs block number 10. Either she has to give or she has to reject. So now you got why they have to forward. Because if they don't forward, then they will get affected. So they cannot gain in future. That's why that motivates them to forward. Whether it may be the transaction or it may be the block also. Let's say in case of transaction, I make the transaction to the last one and she doesn't want to forward. Let's consider I am only connected to her, not with anyone, and she is not forwarding. But what she has done, she has mined a block considering my transaction and then forward to the next one. Now they check whatever the transaction, those are present in their transaction pool or not. So I have sent my transaction, but that's not forwarded. But she has added in her block. When it goes to the next level, they find that no, this transaction is not part of the transaction pool. It may be cheating, or it may be malicious. She will drop the block. Okay, then she cannot get the reward because the majority, the longest chain is considered as the main chain. Until your block is taking part in the main chain, you will not get the reward in case of Bitcoin. But in Ethereum, the ghost protocol is there. There you will be getting some of the rewards. So this motivates the people to further forward the block or the transactions. So now let me come to the non-cryptocurrency application. So we have taken that vehicular network. I was telling about that authentication. So what we said is, there is no currency involved, but if you are going in the traffic, okay, if there is a signal, okay, red light is there, when you go, that you will be getting the green path. So always, because you have contributed, you will be getting the green path. And when you go for fueling your vehicle, there you will get some discount. So in this way, we have said that the encouragement can be done to contribute to the blockchain. But even in that case also, you might have seen the photograph of the Bitcoin data center, the mining data center. It is huge. I will show you the reason why it should be huge. That much nobody will invest. See, you know, in Ethereum, earlier it was proof of work, now it is proof of stake. I hope you all know that. Whoever invested for that infrastructure, what they will do with that? Because that infrastructure is not required with proof of stake. So either they have to move to Bitcoin or they have to use it for some illegal purpose. They may go for cracking the cryptography algorithms. Okay, so this is what happened. And another issue they have faced when the Ethereum moved to proof of stake. So what the proof of stake says is, you have to lock your ether for a period of time, then only you are considered as you have the stake and you can go for the mining. Mining in the sense you can generate the block. There are also mining involved, but with less difficulty. So what happened? People were going for staking it. They were not making the transactions. The founders were worried because the number of transactions are reduced. What will happen if the number of transactions reduced? The demand will reduce. When the demand is going to reduce, the equivalent exchange rate will reduce. Because when I will get the chance for mining in Ethereum, if I have so much money and that is locked for a period of time, then only I will get the chance. So everybody has gone for locking it. So after that they changed some, they changed the model and they make people to make the transactions. Okay. So now if it is the proof of work which needs the high computational power, then we cannot build the non-cryptocurrency application. Okay, that's the reason the proof of stake also required, or other cryptocurrency protocols can be used. So the first issue is the computation. Consider that there is no proof of work or PBFT. Okay, I will talk about that in some time. So then the storage. So the blockchain continuously growing. Okay, it should never stop. Let's say if the block stopped, can we announce that that application is dead? If the blocks 1, 2, 3 it is coming, it stopped in block number 10 for a period of time. Can we announce that that application is dead? We have to announce, because people have to make the transaction when the transaction is considered as final, when it is committed into the block, and the block should be accepted by the majority. But what happened here, there is no block getting grown, then whatever transaction is happening, that is of useless. So that means the application is considered as dead. So now the block should be keep on growing. When it is keep on growing, from genesis to whatever number we have to store, and you think of the storage requirement. Okay, so now the storage requirement is not an issue. Earlier what happened, I bought my first pen drive which is of 256 MB for 2500 rupees. Now for the same 2500 rupees, we can buy in TB. You can see the Moore's law, you compare. Okay, so the Moore's law says that number of transistors on the chip will be doubling every year. And now here if we see, the price is coming down. So there is no problem on the storage, but we have to see the environment also. If it is going to consume more storage, then accordingly we need the devices which will impact the environment. So can we do something for the storage issue also? So that is the second issue. And next is the scalability. So we want to add more nodes. Okay, and you know that now the UPI what we are using, no blockchain is capable of handling those many transactions. So we say that it can handle, for example, Hyperledger, they claim that 10 million transactions per second. But in case of UPI, it is going more than that. So now NPCI also looks for some model which will handle those many transactions, but there is no blockchain exist for that, or no implementation exists for that. And also we want to add more nodes. In case of Bitcoin, we have more number of nodes, or we can add more number of nodes because of proof of work. But if you go for Byzantine fault tolerance, that is a practical Byzantine fault tolerance, it's not possible to scale. In Byzantine fault tolerance, to reach the consensus, I have to approach each and every one, and they all have to approach all others. It is a complex process. But in case of proof of work, that is not required. That's why they go for the proof of work as a consensus protocol. But by the way, proof of work is not the consensus protocol. It's the protocol to control the growth of the blocks. Okay, that is the rate controller. But by taking the advantage of that delay, the consensus is happening. That reaches the majority. That's why it is referred as consensus protocol. Otherwise, proof of work is not the consensus protocol. And next is the waiting time. So this is something very conflicting. So what happened before 10 years or 15 years, 10 years only. If we have to make any transaction in the bank, we have to make it, and the person who is sitting in the bank, he has to log in and check. After that, he has to approve, then only the transaction happens. But now what is happening? The moment you submit, he get the money. But in case of Bitcoin, you need minimum 60 minutes time. See, 10 minutes for, let's say you have a luck, because of your luck, when you put the transaction, immediately it is taken for committing into the block. For example, if you give more transaction fee, then only people will take it quickly. Otherwise, it will delay for sometimes years also if you don't give the transaction fee. So it is taken and added into the block. Immediately that transaction will not be accepted by the receiver, because the proof of work protocol is the probabilistic protocol. There is no guarantee that this block will be part of the main chain or not. So he has to wait for certain number of blocks. As per Bitcoin, if the block number 6 is mined and my transaction is part of it, my receiver can consider the transaction after next 5 blocks with 99% probability. Okay, that means now in 6th block mine is added, in the 11th block only he will consider to accept. Now what happened? 6 to 7, 10 minutes, and the 6th block itself 10 minutes average. So we have to wait for 60 minutes. But the same transaction is happening now within a minute. Okay, so the waiting time is there. So I was telling about the proof of work. It is the old computation. What I have done, I want to test the proof of work. So we know that proof of work is simple hash. Okay, the puzzle solving is simply computing the hash. But we have to compute multiple times until we satisfy that target. So the input is the block header with the nonce. So block header, there are some fields which are static, and this nonce is dynamic. We will be keep on changing and giving it. So what I have done is, I thought that why it needs 10 minutes time, because it's simply hashing. Let me try that. So I wrote a script, and my system is normal desktop with a 3.2 GHz processor, and it's not having SSD and all. The RAM is of 8 GB RAM, and then 3.2 GHz processor, and it was having 4 cores. So what I have done is, I wrote a script in Go language. We can multi-threading is very easy. Just you have to say go run, then automatically it will be creating multiple threads. So I created 4 threads, considering that there are 4 cores, and for every core I have asked to solve the puzzle, considering first the target is 2 power 250. So the hash algorithm what I considered is SHA-256. So the output, you know, it will be from 0 to 2 power 256 minus 1. This is the complete space. So I said that the puzzle is, this is the complete space, but you take the input or find out the input which will produce the output not in the complete, in this only. This, if it produce output in this, then that has to be rejected. So then what I have done is 2 power 250, then it was running, so we can see the real time and user time, and you know, in case of the Linux it will show 3 different times. Okay, so now let's focus on the user time. It took 0.328 seconds. In 1033 attempts I got it. Okay, see, now I solved the puzzle, which is 2 power 250. Then I give 2 power 240 and it took these many attempts. That means I am increasing the difficulty, reducing the target. So then it took 0.356 seconds and it gone for these many attempts. So then further I reduced. So when I go for 2 power 210, my system was running for 3 days and I am unable to solve. Okay, see, there are two possibilities. One, it is not finding the result, so it is running, and another one, you know, the hash algorithm is the deterministic algorithm. Whatever number of times you are going to give the same input, it will produce the same output. The input I am defining, that might be repeating. That's why it was not giving me the proper result. After 3 days, I stopped it because it was summer, and you know the summer of our place. Okay, if the chip burns, then what will happen? I have to answer to my superiors. So I thought that let me switch off, I should not further proceed. But if you see the Bitcoin, the targets will be in this range. Okay, so I will not be with the normal machine, I will not be in position to solve the puzzle. Okay, so that's why if I am going to implement, let's say the Bitcoin implementation, I want to implement in the IoT network, then what will happen? Mining will never happen. Okay, because of that target setting. See, in Ethereum, earlier proof of work, you know, right? In the beginning, Ethereum was also on the proof of work. Bitcoin is also on the proof of work. But in case of mining the Bitcoin, we need 10 minutes average time. But in case of Ethereum, we need only 15 seconds average. You know that the average time for mining Bitcoin is 10 minutes. When the proof of work was there in Ethereum, average mining time is 15 seconds. Both are using the same puzzle solving. So why here 10 minutes and why here it is 15 seconds? So the only difference is they change the difficulty. In case of Bitcoin, difficulty is more. That means the target is they reduce. So we can see in this case, if I set the target near 2 power 240, that means I can solve quickly. So this is what Ethereum has done. But in case of the Bitcoin, they set in this range. So this needs more time. So if such things are there, it is not possible for us to mine in the non-cryptocurrency application. That's why they go for cryptojacking. That means they will compromise the individual machines of someone and then they will do the mining there, or they invest a lot and they have the high level data centers. So these are some consensus protocol, but again I repeat, the proof of work is not the consensus protocol. Okay, so let's consider that as the consensus protocol, and if we see the comparison, the probabilistic and absolute, probabilistic in the sense once we have decided something, there is no let's say that guarantee it will be final. If I mine a block, there is no guarantee it will be final in case of probabilistic. In case of absolute, that means absolute finality, once something is decided, it is final, we will go with that. So if we go for proof of work, proof of stake or delegated proof of stake, these are probabilistic. However, this practical Byzantine fault tolerance and the ripple, and there are many others also there, including avalanche. Okay, but avalanche, they still claim that it is probabilistic. So these are the 5 protocols. And fault tolerance, if we see the proof of work, proof of stake and delegated proof of stake, this can handle 50%, means if the 50% nodes are malicious, then also the network will survive. So I was showing the graph, right, about that authentication model. What it shows is, if in this room we want genuine communication, what it says, even if 50% users are malicious, then also the genuine communication can happen. If it is more than that, then we cannot guarantee the genuine communication. Okay. So here in proof of work, we cannot say the number, we have to say the computational power. As I said in the beginning, if I have more computational power when compared to you all, so I will be leading the chain. Okay. So in the same way, up to 50% computational power is equally divided between the attacker and the genuine, the network will survive. If 1% exceeds there on the attacker side, then they will be leading. That's what the 51% attack. And in case of practical Byzantine and the Ripple, only 33% it can sustain with the attackers, or 20% of the attackers, not more than that. And if we see the scalability, this is very bad, the PBFT, because everybody has to communicate with everyone. However, comparatively, the proof of work, proof of stake is better, or it is considered as good. That's why when the Bitcoin was introduced, see, practical Byzantine fault tolerance was very old, in 80s. That is the consensus protocol. But the anonymous Satoshi Nakamoto has not used it, because it should be scalable. So he come up with the proof of work concept. And in case of the application, these are for public and those two are for the permission network. Now there are so many other protocols. So how the Ripple works, see, I want to reach the consensus. That means I want to take the opinion of everyone. How this Ripple or the fast probabilistic consensus, even the avalanche consensus protocol also works almost. What I will do, these all are connected with me directly, and these are connected with the next like that. So what I will do, I ask a question to all of them, whether I can approve or not. So everybody will give their comments. So now I take the majority, I keep it. Now I cannot take that as the final. The reason is, still the remaining people has to give, but only if I took from these people only. I wait for a period of time. Then again I will ask, what you think about the question. So they may give the same answer or modified answer, then I will take the majority. Then again I will ask, it will go for some number of iteration. At the end of the iteration, I get the consensus of everyone. So how is it possible? Because I asked the question to these people, right? And I am waiting for a period of time. Meantime, they asked their neighbors. They give the response. According to their response, they decided the majority. That majority will come to me in the next round. So again, I wait for some period of time. By that time, it will go to the next level. So finally, everybody solution, or I can say the answer that has come to me. So now I will go for the decision. That's what happened in the Ripple coin, in Ripple. So in Ripple, they divide into multiple networks. They have different subnets, but there should be a connection between one subnet to another subnet. Otherwise, it will be completely isolated. So regarding the storage, so still I have not come to the NFT. I will come to the NFT after some time. Anyway, Sir is sitting, so he has done a lot of work in NFT. So the storage problem I was telling. So what we thought is, let us go for designing some model to manage the storage, because it's not possible to have infinite storage with all the devices, and everybody cannot spend that. So what we thought is, our solution is very, very simple. Anybody can think it. We say that the older blocks are there, just delete it. What is the need of having it? This is our solution, nothing more than that. This anybody can think, right? So that we can save. But there are problems if we are going to delete like that. So I am presenting only two problems, but there are other problems. Let's consider this particular node has deleted all these blocks. It has the genesis block to know that which network it is, and the remaining rest it is having. Now there is other guy coming who is the malicious user. He comes and gives the new chain, which is from 3 prime to some 9 prime. Now if we see the longest chain is this one, that has to be accepted. But he is not coming with this chain, he has created something different. And when he gives the block to this particular guy, node B, he cannot validate. So he is saying 3 prime parent is 2. That parent is this parent, but that parent is not exist because I have deleted. In that case, how I will accept? Now the question is whether I will accept those blocks, that block, the chain of blocks, or I will reject. So this first problem arises if simply I am going to delete. And second, I said that if we are in this, if we are going to have the same genesis block, then only it is considered as we are in the same network. If we are having two different genesis, then we are in the different network. So now let's say that this guy who is the genuine node, he is having the genesis block as G1 and he has deleted some blocks and he is having now 5 and 6. And now there is a new node which is coming, new node that is coming with the genesis block. Now attacker is giving from 5 prime and now it directly goes, attacker is giving some different block which is of another genesis block, another genesis, that means different network. And here this genuine guy is giving the 5th block which is for the same genesis block. Now this one is the longest chain when compared to this. Now which one he will accept? Because he cannot validate. If one comes with one, he can check for the genesis block because one is having the parent. With that parent hash he can map, but that is not present. Then what happens? There is a possibility of network diversion. So the solution is simple, but there are questions to be answered. So what we have done is, you decide the k value which is accepted by everyone. That k is a set, those number of blocks will be deleted. That will be followed by everyone. And here the important thing is, when we are going to delete the block, the availability will not be there. If I want to find some block and that is not there and that contains some transaction, so I am going to lose it. So what we say is, if we all are in this, I may be having 2 GB, she may be having 10 GB and madam may be having 20 GB. So everybody will be having different storage, right? So according to their storage, they will delete it. When they feel like their storage is not sufficient, then only they will go for delete. Otherwise, they will not delete it. So now what happened with the probability, if we see, overall all the blocks will be available at one point of time, provided everybody is having different capacity of the storage. So we consider that. So then we delete those k number of blocks, then remaining will be present and the k will be getting deleted. Whenever there is a problem of the storage, the k will be deleted. But when the k will be deleted, we keep some metadata. That is the hashes, XORed, and we keep it. And why we keep this? If these issues arises, then we will ask the person who is sending, you give me the previous set metadata. With that I will validate. And that everybody should maintain. If they don't maintain, then they cannot give. If wrong person is coming and giving the modified one, then that will be identified. So this is what we have done. And then we have done the analysis. So we have taken different algorithms that exist for the storage efficiency, and we have proposed 3 different models, but all are closely related. And when we go for the Ethereum produces many blocks. If we take average 15 seconds per block, so then how many blocks it can store? It can create. And then we have to see the size of the block also. And if we see, in case of Ethereum, this is the target which we consider 5 GB of storage I am having, 5 GB of RAM, not the secondary storage, RAM only. Because if it is in the RAM, then only we can immediately fetch it. So 5 GB RAM, I can store, or I can have that space only for 2 weeks in case of Ethereum. After 2 weeks, 5 GB is not sufficient. But Ethereum is having one more concept which is called light Ethereum subprotocol. So we have seen the block contains header and the data part. So in light Ethereum subprotocol, it says you store only the header, no need to store the data part. So that reduces. So when that is going to reduce, it can sustain up to 234 weeks. After 234 weeks, it's not able to sustain. It cannot sustain. And there are other models, light chain, they use the skip graph, and there is Liti chain which uses the tree. So we have analyzed all those, but those all are going to vanish at some point of time. That means it is going to exceed that 5 GB storage at some point of time. So in our model, we claim that it will go for long, but availability will be an issue. So in all the models, the same case is there, but what we say is, let's say I am going to delete block number 10, and in block number 10 there are multiple transactions. Some transactions are not required. So you drop those transactions, whatever transactions that is required, that we will be knowing through some method, that you push it to the new block, so that you delete it, so the data availability issue will not come. So this is what we have done, and you see that it can go for 14,900 weeks and 15,000 weeks. This is too high. It goes many years. And if you see what is the lifetime of the laptop, 5 years or maximum 4 years, 4 to 5. So this will go more than that. And I am referring that 5 GB in a device for, let's say, 10 years I am saying. Then this comparison is not correct, because after 10 years we will get with the same price good RAM or more space RAM. But earlier I said the problem is the environment also we have to consider. And I have also analyzed the latency, not with the proof of work. Proof of work I have shown. Let's say the Ethereum is running. On the Ethereum I am going to deploy a transaction. Only deploying the transaction, it is not committed to the block and then comes out. So the transaction, when I deploy, it will be validated. Okay, only that time. After that, the write operation is going to happen. That is almost like the nodes will do once it receives. Okay, so now one is the transaction, write operation, and another one is the read operation. So we will be reading the data. So when I analyzed, so it was using Go Ethereum. That Go Ethereum is open source, you can also download and test it. So in case of the transaction write operation, it was in the range of 15 to 20 milliseconds. But in case of the read operation, it is within only 1 to 2 milliseconds. So if we see why I want to show this is, if you are going to, this is on my normal desktop. Even if we take it to Raspberry Pi or low-end devices, this will not be complex. So we can implement the blockchain on the constrained devices. We can say the IoT devices, we can deploy and we can run it. So it won't be an issue. But the proof of work will be the issue. That's why now there are other protocols. So if you are going to do research on blockchain, so you can focus on the consensus protocol also. And I was telling about the waiting time. So if any transaction is made, then we have to wait for a long time. So Bitcoin has come with the Lightning network, and Ethereum is also having the layer 2 protocols. So in Bitcoin, they come up with this Lightning. So we can say as this also as the layer 2 smart contract. So let's say we all are in the Bitcoin and we know that it needs almost 1 hour for any transaction to succeed. So what happens with this Lightning network is, let's say we both are there, we lock some coin of ours. So my coin and Sar's coin, we lock it with our signatures. And then we come offline, that is the Lightning network, we do the transaction and that will be quick. The final commit will be brought back to the Bitcoin network. So we are forming two networks. So we have Bitcoin, on top of it we are having the overlay network, there we make quick transactions. So in that way the waiting time can be reduced. But here also there are attacks that they have shown, but it's not practically done now. Practically in the sense, nobody has performed the attack. But they are saying theoretically it is possible, which is the flood and loot attack. So now I will move on to the tokens. which is okay. Okay. So any questions, please let me know. Huh. No. Huh. What? Hmm. 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 No, what you are doing for bank? So, no, I don't understand. Let's say the banks are doing their centralized transaction, right? And you want to bring that those transactions into decentralized, or what you are? Okay, okay, okay. Oh, this is something like the study kind of result that you may not get. So they will not give. Okay. See, you cannot do with the synthesized data, no, because that will be biased. So maybe you can talk to some international banks because they may give, but Indian, so they, because I am not sure how many have implemented. Recently, I think 1 or 2 months before, I have seen some more. Uh, no, they say, but whether the complete is there or not. But let me. What you do now? You later you email me, if possible. I will see what can be done for them. Uh, See what we are trying now. I said that we have set up the private network, right? So what we are trying to do now, we are working with Avalanche. So we are trying to bring that private into the public. So we want to connect. So it is like there will be one node running as the public node. The remaining nodes is going to form the private network. So this is what we are trying to. So that's what that hybrid. But anyway, hybrid talks about the permissioned and the permissionless, but we can make this private also. No, it might be done before. But ours is we are going to give the complete hardware that nobody is giving. Right now, Samsung is climbing something. Okay, they have their website, but we have to check it. We have not checked it whether they give the complete hardware or they give the virtual machine. If they give the virtual machine, that may not be perfect. See that simply you take the evidence and store. Okay, but you should not store the actual data. You have to store the metadata. Maybe I will discuss about that. Okay. Ah, transaction. Hmm. No, they have where in Bitcoin you are saying, right? Bitcoin or Ethereum, there is a limit. Yeah, block size cannot exceed of certain size. Accordingly, only you have to fit into that. But now what is happening with that size, the number of transactions are limited. So now what they have done in their improvement, some of the parts in the block header, for example, the signature part, they are not considering, they oh sorry. So they are not considering as size. When the size of the block is counted for that check condition, those parts are not considered, so they can add more transaction. So in case of Ethereum, the gas fees is there. So the gas fees is set. You cannot go more than that. So there is a limit set. No,
May not, it's not required. The latest only should be. Yes, we have actually practically we have not implemented. So we put some T value we can say. Okay, like that only we do. So up to that you cannot delete it. Or we can say in certain cases even we say that you can delete up to you may keep only 10 blocks. Remaining you can delete because if you don't have the storage. But you don't need to worry because if you are having only storage for 10, definitely I may be having for 500 and someone else will. Off-chain storage because you don't have the storage. That's why you are going. See, I said RAM. That's why maybe you are putting this question. But we consider that off-chain storage you are not having. If you are having, you can push everything to that. Later you can verify. But same way, the storage requirement is going to increase. Yes.
I request our external participants to have a tea break. We can move to Cafe 2004 and the session will again resume after 10 minutes. So please be there.
Shall I start? Okay. So now let me start with the token. Okay, so we have the Bitcoin or Ethereum, and now they talk about the token. Okay, so the token we can say again like Ethereum only, or Ether or Bitcoin. So what happen if we are going to convert one? It is like, let's say we have the Bitcoin or Ethereum. So we can consider like this: I have the money, okay, I bought the gold coin, and you know that how fast the rate is increasing for the gold. So I have the money, I bought the gold coin, and whenever I am going to sell that gold coin, it will be having the same value as what will be during that time. So it will remain as same. So similar thing here we can consider, we have the Ether or we have the BTC, that is the Bitcoin, and we are going to keep that as the token, and now that token can be spent later. Okay, but when we are going to have that token, whether it will be considered as the money or it will be considered as something different, that's depend on our application. Okay, so in case of NFT, that won't be the money, it will be just a we can say a value, but that value is not the money, it is the value of some image or some document. So that is what it refers. So there are different tokens, and these are few. So first they come up with ERC20, where they introduce the fungible token, and then they come with 721, which is non-fungible token, then ERC1155, then they brought both fungible and non-fungible, and after that the ERC4626, here they go for interest and all. So now what happened in case of the bank, if I deposit my money, after some year I will get the interest, right? But in cryptocurrency we don't have like that. If you are keeping, you keep it, you will not get any additional money. But in BTC, I said that in 2016 it was 47,000 rupees, now it is 92 lakhs. If I would have bought that time, I would have been having 92 lakhs now. Okay, so that advantage is there, but there is no by default the we can say the interest and all. But in that one they have. So the fungible token I said already, which is the token, the equivalent of something, we are keeping it, and the value will change according to the value of the currency. The token value will also change, but that is considered as a constant token. But now people are talking about the stable coin, so that is different, because there also we will be having the token, and that is based on what the value you reserved on that day. So with that it goes. So here the fungible token is having the equivalence, but in case of non-fungible token we don't have the equivalence. Okay, so I cannot replace sir, or sir cannot replace me, but in case of if I am having 10 rupees note, you are also having 10 rupees note, both are same, so we can exchange, but not in case of non-fungible token. Fungible is having the equivalence, but non-fungible is not having the equivalence. So it says it cannot be copied, substituted or subdivided, and it will be like whoever is holding that, they are holding the ownership. So that's what happens. So we can see this example, this I have copied. So fungible in the sense, if I am having $1 or 10 rupees, you are also having, the both can be exchanged. But in case of the non-fungible, it's not possible. See, even though the house looks same, it is not possible that I will take your house and you will take my house. That's not possible. So that's why it is the non-fungible. And there is, as I said, ERC1155, they come up with the semi-fungible token. So in this, they take the fungible and then later it will become non-fungible. So like if we are going for non-fungible tokens and fungible tokens, then we need two different transactions, and also in some cases we need two different implementation. To overcome that, they come with this semi-fungible. So you can have both fungible token as well as the semi-fungible token, and in some cases the fungible token will be changed to non-fungible also. So for example, you buy the ticket, okay, that ticket is to enter, okay, and that can be exchanged also. But let's say that using the ticket you sit somewhere and that place is fixed, now it is non-fungible. So you sat there and you come out, now we cannot go and replace, that is yours only. So that time it becomes non-fungible. So there we can say the fungible gets converted to non-fungible. So the last one is that ERC 4626, as I said, it allows for going to get the interest. When you deposit the money, that means if you are going to have the Ether or the BTC, there is a possibility you will be getting the interest. But this is for the Ethereum only, not for BTC. So that particular standard says if you have the token, then if you are keeping it for a long time, you will get the interest. So NFT is the Web 3.0. So we have Web 1.0, 2.0 and then now 3.0 people talk about. So in case of Web 1.0, it is like the static web pages. Okay, so we don't interact much. So whatever is there, just we are seeing. For example, if you see my web page, that is static page which follows Web 1.0. Just I am having the information, I am sharing with you. But when you are going to interact with my page, so for example, Gmail, we enter our username and password, goes and it shows, then we say you give me this email and then I will send some email. This interaction brings Web 2.0. So now then the Web 3.0 comes after the blockchain. In Web 3.0 we are going to make it decentralized. In the sense, in Web 2.0 and 1.0 we have a centralized server which gives the data and we interact. So now everybody will be having their own data without any centralized server, and whoever want to fetch that, they will be, because all are connected, by joining the network they can get the data. So the NFT is one of the examples of the Web 3.0. So it's the decentralized web and every users own their own data. So this is the NFT flow. This is again copied from some source. Okay, before going to that, you know watermarking, right? Watermarking is to prove that some document is of yours, okay, and then copyright also we know, okay, we register somewhere. Let's say that I go and register for a copyright, I got the copyright. Who is the owner now? I am the owner, right? Will this be true? I will be the owner of the content, I am the owner of the content. Let's say she wrote in movie, I get lot of news in, I am from South, Tamil Nadu, and there we get lot of news. I don't know whether it happens in the north or not. So what happens, somebody write the script for the movie and another guy steals it, he go and register. Now who is the owner? The one who has stolen and registered, he is the owner. Okay. In the same way, if I am getting the copyright, there is no guarantee that I am the owner. But legally, I am the owner. That means who goes first? Because if you people are not aware that you have to register, I sit with you, learn everything from you and I go and register. Let's say that you all have invented something. Okay, there are, let's say 30 are sitting here or 20 invention is there. I go, I discuss with you, got the idea, I propose to the patent cell, I get the patent. Now I am the owner. You cannot legally prove. You can go to the media and say that this is mine, but that's not going to work. Legally, I am the one registered. Okay, so the non-fungible token faces the same issue. Okay, so here what happens, let's say some image we are going to sell, someone is going to sell. We will see the real example. That image, he doesn't want to go and put in the museum or in the somewhere exhibition, and he doesn't want to sell because there only limited people comes. So he want to make it decentralized. So what he does is he created the content. Let's assume that Bob has created the content and he doesn't know all the things, okay, how to interact with the blockchain and all. So what he does is he put that content into the cloud. So I will talk about the cloud or IPFS. So he hosted there. After, am I making any mistake? Okay. Can we switch off? Oh. So I switched off. Okay, but anyway, meantime we will discuss. That will take at least 2-3 minutes. Okay. It's my mistake. Okay, not the Epson mistake or his mistake. Okay. So now let's say that I am the one who created the content. I am not aware of the things. What I do, I uploaded that image in some third party storage, whatever it may be. Whether it is cloud or IPFS, now people talk about IPFS. I will discuss about that in some time. Huh? Louder. That is the IPFS. Okay, good. So now I hosted and then I contacted him because I considered that he knows all the things about the blockchain. I contacted him. Now you be the owner and then you sell it. So what he does is he create the token and the token is minted into the blockchain, Ethereum blockchain, where there is a smart contract to run the NFT. So now she want to buy that. Okay, because my intention is I have drawn the image, I posted, I want to sell it to some people. So that's why I gave to him to put into the NFT, he minted it. Now she want to buy. So when she is coming to buy, she sees the image, accordingly there is a bidding happen offline. How much will be the rate? After that she pays that equivalent Ethereum to me, Ether to me, and then what happened now, the ownership which is with me getting transferred to her. So I sold it. Earlier I was having the ownership, but I took the help of him. So now what happened, since I got the money from her, so I am transferring the ownership. So that means here there is a transaction applied. That transaction says this token number is now ownership is changing from this account to that account. Now she will be the owner. And like that it will be going. Okay, here the question will come whether she can take the copy or I can take the copy and sell it. Okay, but you cannot sell there, but you can sell in some other blockchain network. Okay, that we will discuss. So this is what represented in this particular diagram. So in real scenario, if we see the digital artist, he was called as Beeple, but his name is Wickinson something. So he put his first collage, which consists of many photographs, that whatever he has drawn in the first 5,000 days, and that was sold for $69 million. Okay, and also the Twitter shareholder, the co-founder, Jack, his name is. So he also sold the Twitter content. So that simply says that it is the first Twitter or something. So that content also they sold using the NFT. And during that time, NFT was considered as something very popular. It was like this. Now the curve has come down. And my students told me now it is little increase, but still I have not accepted that. So let's say that how you will purchase the NFT. Assume that the token is created. Okay, I will talk about that. The token is created. Now how you will purchase? If you have to purchase, you need the Ether. Then only you can purchase. So you will pay the equivalent Ether and then the ownership will be transferred. Otherwise, sometimes what happen, if we know each other, she may give INR, then I will make the transaction that will be changing the ownership. That is also that is also possible. So now let's talk about the security. The first one is the image or any content that cannot be stored in the blockchain. So the important thing we have to consider, you cannot store massive data in the blockchain or massive size data in the blockchain. That is not suggested. The reason is already blockchain is going to have the overhead. And when you are going to store the data in the blockchain, everybody has to store. Let's say if you are going for 1 TB of image, all of them have to store that 1 TB, and you see the consumption, storage consumption. And second, the 1 TB has to be shared with all, then network bandwidth. That also we have to see. So it is suggested we should not store the actual content in the blockchain, we store only the metadata. So that's what the first issue says, we are not going to have the actual data, we are going to have only the metadata due to the storage issue. So the next is, as I said, that only we have to store the hash, and now when the transfer of the ownership happens, so what ownership is getting changed? See, let's say the data is stored in some third party place and the metadata to access that is the token. Now when I am changing my ownership to her, what she is getting in the ownership? That pointer only she is getting, she is not getting the image. So this is the issue. And now I am storing the image in some place, right? And the index is shared and she is selling to someone. And this storage, if this is killed, what will happen? Gone. Okay, that's why we need to have multiple copies, otherwise it will go off. This is the first issue. And the second issue is the NFT is the smart contract. Okay, that's the decentralized application, but it is not DAO, it is not autonomous, it's only DApp. Okay, so the application is running, that is run by some organization. If we see, all the DApps are centralized. It is running on the permissionless network, but the DApp is made by some organization. So then it is centralized. So I do all the tasks. If the NFT goes away, that the owner goes away, or the owner cheats, then the things are gone. This is the second issue. So there are many questions to be answered. So is it possible to do unauthorized selling? So I said, right, I have sold her. Now can I sell the same image in the same network? Why it is, you know BitTorrent, right? But anyway, these days people are not using. So during like before this Web 3.0 and all we talk about, before the IPFS, so people use BitTorrent. So where the movies are there in various locations, you can download and watch those movies. And there you can have multiple copies. So if I download, I will have, if somebody want, it will go from my machine also, that movie. So that's what BitTorrent does. IPFS is also similar to that, I will talk about it. But in case of BitTorrent, for the same movie, there will be multiple pointers. In the sense, metadata will be multiple. But in case of the NFT, for one data, there will be only one metadata. Okay, we consider that case. Now I created the image, I sold her. Now can I sell that image to someone else also? Same image. See, I stored, created the metadata, I sold her. Now the same metadata, it's a digital copy, right? I can take any number of copies. Can I sell to her? It should not be possible because the double spending is controlled by the base layer. Ethereum is controlling that. Okay. But now the second scenario, this image, the first scenario is image, metadata created, I sold, and I am trying to sell her also the same metadata, it's not allowing. Now second scenario is, first one I sold, now I am taking the copy of this image, again I am creating the metadata, and then I am trying to sell. You see, both are same. So now, do you think in this case it is possible? See, it should not be possible because that's why I was referring to BitTorrent. In case of BitTorrent, you will be having multiple metadata for one, but here you will be having same metadata. So if the same metadata is there, when I am going to insert that new image, they will map whether it is already there or not. Since it is there, so it will not be allowed. So in the two scenario, it is not possible. Now what I am doing, the same image, I create the metadata, I put in another NFT. I can sell it, right? So now this is the major issue. It is always possible because both are two different networks. So here I sell to someone and here there I sell to someone, and if there is third one I will do the same thing, or someone else may be selling there, I took his copy, I am selling in multiple places. So that is also possible. And the second problem is the initial copy fraud, which I already discussed with you. Okay, who will be the actual owner, that we don't know. And so when you are going to buy any image, first you want to see, right? Then only you will buy. Now, while seeing that itself, I take the copy. See, in music, we get lot of news, right? People stolen this music from that movie and this, they make small changes. If there is a small change, the hash value will change because we know that hash is random and it is deterministic, and if any small change in the input, there will be a massive change in the output. So that they will do and create it. So this is also another issue. See, if there is a big image, that Mona Lisa image for example, you give it to the hash function, digital copy, you give it to the hash function, it produces the output. Just remove one pixel, don't remove, flip only one bit, then it will give different output. So we are going to get different metadata. So then that is, people can sell like that also. So that issue is also there. So then what about the legal issue? So I was reading one article. So there are some court that accepted the digital evidence through as NFT, but some were not ready to accept. The reason is, see, if I am the owner of the image, I am having the ownership, I produce it. Next time I may not produce because I am holding it, right? I deny to give. So what will happen in that case? So they are saying, considering this, we will not consider that evidence. But there are, in UK also I think, they have accepted the NFT based evidences. So the formulation is also the problem. And now how the NFT is created, let's take that same image. Okay, so there is on chain and the off chain. So in case of on chain refers that we do all the activities on the blockchain. If it is off chain, that means beyond the blockchain. Okay, so let's say that I have the image, I store it into the IPFS or the cloud. So this refers off chain. Now that metadata I am bringing and posting it into the blockchain implementation, that's the smart contract. So there it is referring as on chain. So in IPFS, in cloud, if you want to search the data, we need to have the index. If any search we want to do, we need to have the index. Based on that only we will be searching. So now in this IPFS, in cloud, the IPFS is the file number. Okay, if we take the array, normal C integer array, what is the index? 0, 1, 2, 3, right? So that similar to that in case of the cloud. But in IPFS, the index is different. The content is the right, content is hashed, and that hash is the index. Okay, in the IPFS. So if you want to find out the location, then that hash is required, not 0, 1, 2, 3. So what happens is that is referred as the content identifier. Now let me say that I want to host some image. So when I am going to host the image on IPFS is having multiple nodes. So in detail I will discuss. So I posted there, after posting it, there is a hash value get computed. So that is the content identifier I got. So with that I create a JSON file, and now that JSON file is the metadata file. Again that JSON file is stored in the IPFS. When I am going to store that JSON file, for that again the index is created. That index will be stored in the blockchain. So when I am giving the ownership to her, that means that URL, that hash index, that only I am giving to her. So let's say that this is the content identifier for an example, and using that we can fetch this image.png. That means this is the location, and especially this part is the identifier which is referring to that hash. So I was telling about the JSON. So this is the JSON file and this is the actual image link. So the image is stored in a location, that index is this one. After that we give some description and also we can give different weights, like here it says that for some information, for let's say I say some image but I am selling some other image. So it says that in the background it is blue color and this image is very rare. So like that I can give some information. So now this JSON is also getting stored, but where it is getting stored? Not at the same place. Image is in one place, there is a possibility the JSON will store in other place, and for that there will be a pointer derived and that pointer will be stored in the blockchain. Okay, so that will be put as this. So the minting happens, mint is the creation of token. So the token ID is 1. So normally they don't give some random ID, they go for sequence 1, 2, 3 like that. So the token ID and who is the owner, since I have put the minting happens, so I am the owner and this is the address. This address is for the JSON file. So once I go to the JSON file, there the pointer is there for the image, then I can go for it. So when I want to sell it, so it will be like I will mention what is the token ID I am selling and then the respective price will be, money will be taken, then the transaction happens. So now let's briefly discuss about the IPFS. So we see that this is the centralized model. We know the data will be present here and all will be accessing it. And in case of the another one, sir, how much time I have? 10 minutes. Okay. Okay. So in this case, this is the peer-to-peer network. Okay. So we don't see any connection like this. There are intermediate nodes. This shows the mesh topology, but in real world we will not be having. There will be routers and all, but there is no server. So everybody is like talking to each other. So this is what the system that is getting used by the IPFS. Okay. So now let's say these are the nodes. Okay. So it uses the distributed hash table to store. Now for all these nodes, they are arranged in a circle. Let's consider they are arranged in a circle and that circle is going to have a value. There are n number of points in the circle, everything is indexed by that point. And now if any node want to join that IPFS network, that node ID, so normally node ID is the IP address. So the IP address will be hashed and that hash output comes, right? That output belongs to these values in the circle. So the node will be attached to that point. So like that everybody is attached, so we consider that they are attached like this. Now the data is coming. Again for the data we are going to compute the same hash and that will lie in one of the places. So it may lie here, it may lie here somewhere. And when it is going to lie here, then it will be stored in this machine. So this is what the distributed hash table format. So this feature is getting used in the IPFS. But in IPFS, the nodes are not selected like that. What happened? The nodes are arranged in the circle. We consider that I want to store the data into some machine. Whatever node is approachable to me, I stored there. Okay, the JSON is stored and let's say the content is, the actual image is also stored. Now there is a pointer, that pointer is put into the blockchain. So my job is done. Now someone is coming to search that. Okay, so it is stored here in one of the machine, it is stored. Now that pointer is taken. Now that pointer will be used to read. And now with that pointer, we don't know where the data is stored. Because there are so many nodes, maybe one node is having that, we have to find out what is that node. So how that is found, it is just using the XOR. And you know the XOR is having the property that it is inversible and it is commutative also, and also it will give the randomness. Okay. So since it is having the, and also we can find the distance. So because of that reason only the XOR is used in this. So what they do is the content ID, normally the complete content we don't consider that there is a keyword for that content. So she want to search, she gives the keyword. Okay, and when she gives the keyword, for example, I am there, I have my neighbors. Okay, there are lakhs of nodes. I will not store all the nodes ID. I will store some nodes ID that I will tell you how I will store. So now once she sent the content, I have the list, right? With that I will see I will look into the XOR. Each and every ID will be XORed with that keyword. So what ID is going to have the less XOR value? See, 10 list I am having, 10 nodes address I am having. She is giving one value. I XOR with all the address. And now out of this 10 XOR, one address is going to have the lowest XOR value. Now I will approach that node. And if that node is not having, see here we see what distance we are seeing, the node address and the content address distance, because the data is stored considering that. So she sends to me and I found the nearest one. So I asked that nearest one, are you having the data? Let's say if he is not having, then what he will do, he will search in his list by doing the same XOR operation. Whatever is lowest, then he will go. Finally it will be found. And it will be found in the log n attempts. We don't need n attempts. So there is a tree form found and in that it will be identified. So now the complete scenario I will tell you. Now I have created the image and you all are the, let's consider this side is the IPFS. I go and store on her machine. I store without checking the distance and all. I just showed. Now what she does is she takes the XOR of what content the keyword I have given and she is having some neighbors. She compute the XOR and whoever is having the lower XOR value, she informs to them that I am having this content. This is what she does, but content is with her, only she is informing to others, whoever is having the closest value, the distance to them, she is informing. So now let's say she is the one having the closest, she is having. Now the job is done, it is stored and this metadata is stored in the JSON metadata is stored in the blockchain, let's consider. Now SAR wants to access it. SAR took the metadata, that the pointer of the image from the JSON file from the blockchain, he extracted it. Now to whom he will go? So what he will do is, he will go to anyone, whoever is known, he will contact that person. Now that person will compute the hash difference. The hash what is the keyword and the address list what he is having, and in that he checks who is the closest. Maybe he found the closest as she, but she is not having the content. So now the request is transferred to her. Now what she does is, she again take the keyword from her list, she XOR and checks. Maybe possible she is found. Now she says I am having the content, she gives the content. So this is the way the IPFS works. So we can see this, the circle I was telling about. Okay, so from 0, 0 to 4 times 0 to 4 times 1. So that means the circle is made. Every node and values are linked with this. Okay, and actually this one is considering the XOR for storing also, the actual data storing. But for actual data storing, IPFS does not go for it. Only at the time of retrieval, it completely depends on XOR. For storing, anybody can keep it, but will be informed to the lowest one. So that's what happened. So now let's say that this is node 5 and node 5 is going to maintain the list, because log n is important. So when it is going to maintain the list, the complete entry is there, right? So in the complete entry, there are, this is the tree, complete tree we can see. In the complete tree, so this is one subnet, second subnet, third and fourth, if we classify. And from each one, there will be one node that will be in the list, not more than one. See, let's say there is a k value, and according to the k value we will choose. If you say k equal to 1, then from all group only one node address will be there. If it is 2, then 2 address will be there. So what's going to happen when this guy is going to have the list? So he is having in all the lowest one. So that will be used to index. This is what happened in the IPFS. So normally the NFT stores the data in the IPFS, the metadata in the blockchain. That's the smart contract. So already she said that interplanetary file system, that's the full form of IPFS, and the process what I explained. So the IPFS uses Kadamlia network. So the Kadamlia network process is this. It's not completely using the Kadamlia network, partially it is using the Kadamlia network. Okay. So now let's say that I was attending one lecture. You must have heard about Estonia, right? That's a country and they do good in governance. Okay, they have everything in blockchain like network. So what they do know, whatever activities that are happening, so that will be put into a tree. Okay, so I am unable to recall that tree name. No, not the Merkle tree, the KSI, they call it as KSI blockchain. So they put the whatever the all the government activities, say they put in the blockchain, consider as a tree only. They put accordingly the root hash will be created like the Merkle tree, and now that hash gets printed in the newspaper, in the daily newspaper, and it goes to everyone's home. You cannot do any change. So they do like that, but their population, they say it is 1.5 lakh. Okay, and in Kanpur itself we will be having more than that, right? So it's 1.5 lakh or 15 lakh, something only they are saying, not much. But here it is not possible. Okay, not possible in the sense there are other constraints, okay, that we cannot discuss. So in that case, I have attended one of the professor's talk. So they said that they want to have the health data as an NFT. Okay, and my data, I go to a hospital, I have it. When I go to another hospital, I will transfer the ownership. But my question was, see, if I am the patient, data is created, who is the owner? I am the owner, right? Even if I give the permission to someone, it is for a period of time, and I cannot give completely the data for him. They may take the copy, that is different case. So there are various issues when we are going to implement the full secure and private blockchain based e-health. That's too many issues are there. We analyzed, and almost like I say, it is not possible to ensure the complete privacy. Okay. So now in their case, they have considered it's an NFT and we will transfer the ownership, because I go to her, let's say she is the doctor. So I do the consultation with her, the token is created, the data is created and it is stored in the cloud or IPFS, the token is minted. Now I go to the next doctor, I have to show that report to the next doctor, and now we know here, right, we don't show that because we want to take multiple opinion and we don't disclose, because if we disclose then there will be a biasness. Okay, so we don't disclose that. So then here what happened, the data is also get split, but the issue is not that. So now I go to her, she has given me the data that NFT has created. Now I have given the NFT to her. Now she is the owner of the content, but actually I am the owner. Okay, so in e-health we have to see how we can apply the NFT. So we cannot just like that apply the DPDP Act. We know that I am the owner and I should have the ownership. I can give for research purpose or some other purpose, but whether I can completely give the ownership to someone or not, that we have to see. So this is the model that we have proposed, and also we have analyzed. See, the very important thing, when you go for using blockchain in any of the applications, you cannot just like that go and climb, because everybody knows if you are going to use blockchain, there is a overhead. Okay, you have to justify that this overhead will not be affecting. So that's what the analysis I have done, or we have done in the case of e-health. So what we have done is, we consider that there is an application, e-health application, there is no blockchain involved. there is an application where blockchain is involved and the data is stored in the IPFS or cloud. So then when we do the analysis, the storage space, because Ethereum, the blocks are keep on growing, the storage space will increase. But if we store the data, it will be almost same. Whether you go for blockchain based or non-blockchain based, the medical data will be same. But only thing is the metadata is additional and that will be in bits. Okay, that won't be a much over it. And if we see the block, when you are going to have the blockchain, they have to interact for sharing the transactions and the blocks. So for that, if we see, it will be taking 20 Gbps additional. If you share the actual content, then it is 3 Mbps. So total it is coming to almost 23, I think I have missed this, it should be 23 Mbps. So this should be Mbps, not the Gbps, okay. So now 23 Mbps these days is nothing, okay. So in that way we can justify. However, we see the storage, it is increasing, okay. So now I am going to give the conflict answer. Earlier I said the value comes down, the cost of storage comes down, but we have to change the environment. Now I am going to claim here, see it is increasing the price, the storage size, but the price has come down, so it won't be an issue. So you see the conflicting answer that I give. Okay, so like this we have to give the justification. Otherwise, see, we can implement in applications, but we have to see whether it is really possible or not, and you have to convince your higher authorities. So you have to keep the justification and then prove it. So let's say that e-health one, we have to still debate whether we can go for the NFT or not. And next, in case of the digital evidence, okay, these days people talk about keeping the forensics report on the blockchain, not the data, the metadata into the blockchain. So we can keep it so nobody can change it. But there are many issues whether people will go for or not. See, for example, let's consider the accident case, and we know if someone is drunk, he is not eligible for the insurance. But if they want to, first let's say the FIR is filed considering that so and so. Now if they want to change later, it's not possible because it is already put into the blockchain. Okay, so that issue arises. See, sometimes it may be legal also. For an example, let's say I enter the student's attendance. I made a mistake, I want to correct it. But if blockchain is not going to allow me, then it will be an issue. But we consider that there is a redactable blockchain where we can modify and still it get accepted if I go through proper channel. Otherwise, it's not possible. But here we will have the digital evidence and it cannot be changed. And you will be having as the NFT. Okay, and you can change the ownership from one to another. But I said already the problem. The problem is, sir, only 1 minute I will complete this. Okay, so the ownership in the digital evidence, if we see in the forensics, that respective police station is responsible or the officer who is for the investigation. So he is responsible to do it. So he will be the owner and he has to keep the ownership for long. So it can be created as NFT, but we cannot transfer the ownership. It may be possible, the higher authorities says that now you submit the file to some other person, so then the ownership can be changed. So the problem is the data is in IPFS or the cloud. So we can say instead of worried about the IPFS or cloud, let's say our government is going to have the data center and it will be there. Okay, in that case there won't be an issue. And now I'm going to some of my research. I will not take much time. I will guarantee that in 5 minutes I will finish. Okay. So this work we have done recently. This is going to appear in one of the conferences. So what we have done is, normally when people do the security analysis of the blockchain, so when any blockchain application is built, it's not only the blockchain implementation. So blockchain is their base layer. On top of it, we will be having the smart contracts. So that is additional. And then how we interact with the smart contract. We don't go to the command line and code it. So for example, Remix, that's the web browser add-on. So the browser also comes, that means the web application also comes into that, and then the database comes into that. So if you see the ecosystem, there are multiple components come. So we have considered there is a web application involved, mobile application involved, layer 1 smart contract, blockchain base layer, and the user who is going to interact, because they may give the password, right? So then we analyzed based on the various attacks that happened in real time, and we found that when you are going to design your blockchain application and if you are going to propose your security model, you should not consider only the blockchain base layer or the layer 1 smart contract. You have to consider the mobile application and web application. For example, we analyzed this considering the e-health, whatever we have done, and we see this, there are security risk involved in all the categories. Even though in the base layer it is more, and in some cases layer 1 smart contract will be having more, but here also the vulnerability is there, the risk is there. So if we give the weakness here, then attacker can exploit. And one thing, so recently I wrote this document. So what happens now, we talk about the blockchain. Blockchain is not completely new technology or concept. It includes distributed systems, it includes data structure, it includes computer networks, it includes the cryptography. Cryptography plays the major role along with the distributed system because of the consensus. So now the ownership is proved using the elliptic curve digital signature algorithm. Okay, and then now in the layer 2, they are going for the zero knowledge to ensure the privacy. So there the zero knowledge snark or zero knowledge stark is getting used, but zero knowledge snark is based on the pairing concept, elliptic curve pairing concept, and the stark is completely different because they claim that it is quantum secure. It is quantum secure because it's not using the elliptic curve. So what I have done is, I thought that people many times they read from various sources and they don't get the concept clearly, and I assumed like I am the new, anyway I am the new for this concept. So I read using various sources including ChatGPT, and based on what are the questions I will get, so accordingly I have prepared the document. Okay, so my objective is, or our objective is, if somebody goes through this document, after going through this 73 pages, they should be clear on the concept and they should not get any questions out of that, because if any question they get in their mind, that question is answered in the coming. Okay, because I put the question also. Okay, so if you go for ChatGPT, because everybody claims ChatGPT gives everything, that will not give this much, and also ChatGPT gives me sometime wrong results also, and I have to spend 2-3 days to analyze. Okay, so based on that I prepared, and whoever wants, right now I have not made it public, I am sharing with the known, and in case, because I am taking the feedback, because if people say that this point is not clear, then I will answer that in the document itself, so that I will upgrade. After that I will make it public. Okay, so it will be open source, I will not go for any book, we will not go for any book or not, it will be there in our website. Okay, so if anybody want, I will share this with you and then you can give your feedback. Okay, here I stop, thank you so much. You have questions? Yes, please. See, for the privacy issue only, this ZK snark is there, and in that itself there are various protocols like Groth is there and Planck is there, and everything is having certain issues. So if you want, you can take those and try to solve that. See, the objective is it has to give the privacy. There are models, but those are having weakness. See, for example, if we take Groth 16 or Planck, that is vulnerable to quantum. Okay, so that's why I have included Stark in this, which is based on the Merkle tree, that is the hashing. So it's not vulnerable for the quantum computers, but that is considered as heavy. Okay, so you may think of building the new zero knowledge protocol which will be secure against the quantum. At the same time, it won't be heavy. See, for the scalability, you have to focus on the consensus protocol. Okay, because of that only there is a delay. You mail me. Okay, Venkat at Triple IT. Any other questions? Okay, thank you.
Engaging and insightful session. Your insights on blockchain technology and NFT for evidence management systems gave us a fascinating perspective on how blockchain can enhance transparency, accountability, and security. On behalf of PSIT Kanpur, we extend our heartfelt gratitude to you, sir, for sharing your valuable time, expertise, and wisdom with us today. Thank you, sir. May I now request Head of AI Department, Dr. Sunil Kumar Vishwakarma sir, to kindly present a token of gratitude to Dr. Venkateshan Subramaniam sir. Thank you once again, sir, for gracing these programs with your presence. Thank you. Thank you once again, sir.